Hi, this is Bill King with Water Online at WEFTEC2014, and we've made our way to the Hach booth. I'm here with Terry Stange. And Terry, you're going to talk to us a little bit about the TOC Analyzer, is that correct?
Yes, that's correct. Here we have the Hach Biotector B7000. It's an analyzer that was developed specifically for wastewater applications, both municipal and industrial. And unlike many other analyzers, the target market for this was wastewater. Many people often develop analyzers for clean applications or lab applications and try to extend the technology to work in wastewater applications, and that's very difficult. Many times you'll have to add dilution, you'll have to add some kind of homogenization step to make sure the sample is consistent, or you'll have to add filtering. All of this is designed to work at a range that you really didn't expect to work in or design the instrument for. But the B7000 was designed from the beginning to work exactly for a wastewater application, to handle fats, oil, greases, salt, all of these things that are very nasty to deal with, very difficult to analyze. They typically clog the tubing, clog the analyzer, cause a lot of maintenance issues. But this analyzer was designed specifically for that right from the beginning, so we've been able to put in a lot of components, reliability, a lot of technology that it fixes those things right away.
When you talk about it being designed specifically for wastewater, what does that mean in terms of the materials used or the size of components? Can you talk a little bit about that?
Exactly. First of all, you start by looking at the level of TOC that you're trying to measure. In some cases it's up to 100,000 part per million, which is the highest level of TOC before you start to see phase separation. So to handle that, you've got to have a strong oxidation system to begin with that will convert all of that TOC to CO2, which is what we measure. In addition, you have to have tubing that can handle this kind of material. Tubing that doesn't get clogged, so you don't have to have any filtration in front of the system, so you can handle all of the particles that are potentially organic particles that come in. So between no filtering, no dilution, strong oxidation system, and what's most important about this analyzer is a self-cleaning module that once the analysis is run, we run chemicals back through the analyzer to clean out all of the things that may have deposited on the tubing.
Yeah, I was going to say, one of the things with wastewater is obviously it can be highly corrosive. Product that's used in wastewater applications often requires an awful lot of maintenance. Can you talk a little bit about the maintenance required for this analyzer? Sure.
This analyzer has a 6-month maintenance interval. So 6 and 12 months we recommend changing some tubing, changing some relays, some small components. But the fact that we've designed the analyzer to have large tubing that self-cleans, this extends the life of the tubing. So there's not a lot of maintenance required for that. The oxidation system itself is self-cleaning. So there are oxidation technologies out there that after you run them for a while, they deposit ash and they deposit material that has to be removed. This instrument here uses a self-cleaning mechanism to clean not only the tubing, but it also cleans the reactor as well. And we've got materials in there that are very resistant to corrosion. You know, we have Hastelloy material around the NDIR detector, so special components, tubing, materials all went into this to handle the dirty environments and the corrosive environment that you mentioned as well.
Well, let's take a closer look.
Sure. I wanted to show you some of the components that make the B7000 the reliable wastewater analyzer. Let's start with the mixer reactor down in the bottom here. What we've done is take many of the components used to circulate the sample and we've combined them into one mixer reactor. And everybody knows that when you reduce the components, the number of parts that you have in an analyzer, you usually see improvements in reliability. One of the main things that keep this analyzer up and running is a self-cleaning recirculation system. So after we introduce the sample into the analyzer, we oxidize the sample using the mixer reactor. The oxidized material, the liquid, is stored in this container over here, and then actually we reverse the flow of the pumps and we recirculate that oxidized material back through the system, and what it does is it ends up cleaning all the tubing out prior to the reaction. So if we get some contamination on the tubing, something that's very sticky, difficult to remove, this self-cleaning mechanism will remove that, and it runs every cycle. So it's not done every 6 months or every 3 months. After every oxidation, after every analysis, we clean the tubing back to the chamber, reaction chamber. What you can't see on the outside of the instrument is something that we probably should mention. There's no filtering and there's no sample preparation on the outside of the instrument. We take the raw sample in as is through the reactor and analyze it as is. This reduces time, this reduces cost, and this also, as I mentioned earlier, improves reliability by not having other components that could fail.
And so Terry, how many applications do you have of this TOC analyzer?
Well, installed base, if that's what you mean, we have about 700 to 750 installations in the US. And they cut across chem, petrochem applications, municipal applications, primarily wastewater applications, although we do have some in airports, you'd be surprised to know, measuring airport de-icing fluid. So there's probably, let's say 10 different applications where the analyzer is used to measure wastewater. We have about 750 analyzers installed today.
Great. Well, Terry, thanks very much for your time today.
Thank you very much.